Okay, this video is going to be from me working through the problem from the 2023 Calculus BC exam number 1. This is number 1, so it's with a calculator. Okay, you see we had a pretty good average that year, okay, well above the global average. So let's read through this. A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline, is modeled by a differentiable function f, where f is measured in gallons per second, and t is measured in seconds since pumping began. So f is the rate that gasoline is being pumped into this gas tank. Selected values of f are given in the table. Okay, using correct units, interpret the meaning of the integral from 60 to 130 of f of t. Well, f of t is a rate, correct? F of t here is a rate. And if you integrate a rate, you get an amount, right? F of t is the amount in. I'm sorry, f of t is the rate in, yeah? F of t is the rate in. And if you integrate the rate in, you get the amount in. From 60 to 135 seconds in this case. Okay, so I'm going to respond to that first. I didn't leave any space. I just copied this straight from the document on College Board. So I'm going to come down here and put all of my responses down here. I'm going to try to squeeze it in. I encourage you guys to go and work on another sheet of paper, but I'm going to try to squeeze it all in. Okay, so the integral from 60 to 135 of the rate in gives you the amount in. Now, we have to use correct units. That means units on time and units on the amount. Okay, 2 sets of units. All right, so this gives the amount of gasoline pumped into the tank in gallons, the amount in gallons, from time 60 to 135 seconds. The other way that you could say this is it gives the number of gallons pumped into the tank from time 60 to 135 seconds. They are looking for the meaning of the 60 and the 135. They are looking for units on the meaning of that. So the meaning is amount, they're looking for units of that. And of course, they're looking for the meaning. All right? Okay, so I feel confident we got that one right. Now, use a right Riemann sum with 3 subintervals, and they give me the subintervals to approximate the value of this integral. Now, let's recall when you're doing a Riemann sum. When you're doing a Riemann sum, you're not doing a smooth curve. You're just doing blocks. You're doing rectangles. So if we are doing a right Riemann sum, I need to use the right f value, and we're going to multiply that by each change in time. And they tell me the change in times. They tell me it. They tell me which times to use. So I'm going to use those, right? The table starts at 0. I'm not going to start with 0 because they didn't tell me to start at 0. They told me to start at 60, so I'm ignoring 0. And they told me to stop at 135, so I'm not going to go all the way to 150. I'm only going to use the intervals that they tell me to use. Okay? So right Riemann sum. Let's come back here. So I am now approximating that definite integral with a right Riemann sum. So right f. So I'm over this first time interval, the right f value is the 0.15. So I'm going to write 0.15 times that change in time. That change in time is 90 minus 60. And yes, it is okay if you write 30 for that, but we don't have to, okay? Then we go to the next delta t. The next change in t is 90 to 120. So I'm only looking at 90 to 120. The right f value is 0.1. So now I'm using 0.1 for the right f value. Change in time is 120 minus 90. We just have one more to get, and that is 120 to 135. The right f value is 0.05. So 0.05 times 135 minus 120. Okay? So that is the right Riemann sum. That is the approximation for that definite integral. This is a calculator acted problem. That does not mean I have to add that up. I'm done. I'm going to part B. Do not waste your time punching that into your calculator. It's a time waste. All right, part B. Must there exist? As soon as I see this, I am thinking IVT, MVT, or remotely possible EVT, extreme value theorem. Okay? EVT only guarantees an absolute max and an absolute min. It guarantees an absolute max and an absolute min on a continuous function. Okay? I've seen that very rarely, but I have seen it in FRQs. Must there exist a value of C between 60 and 120 such that f prime of C is 0? It's not EVT. It's not talking about an absolute max or min. It's saying that f prime of C is 0. The table has f. They're asking me to guarantee a C that has f prime of 0, so I know I'm using MVT. Okay? If they were asking me to guarantee f of C was some number, then I would be using IVT. But this prime here makes it MVT. Okay? So MVT. So my mind switches gears to MVT. What do I need for MVT? MVT, I must be able to say that the function that's given in the table is both continuous and differentiable on a specific interval, but in these FRQs, they're usually continuous and differentiable everywhere. So what about this problem tells me that f is continuous and differentiable? They told me that f was differentiable. And if a function is differentiable, it must be continuous. So I will state f is both continuous and differentiable for all values of x, not just the intervals that I need it to be for this, but for all values of x, since f is given to be differentiable. Be sure to say exactly what it is given to be. It is not given to be continuous. It is given to be differentiable. We have to know. We have to be able to state then that f is continuous because of that. But it wasn't because it was given. So don't tell me it was because it was given. Okay, now they're asking me about this f prime being 0, and they give me an interval. So remember, for MVT, that means that change in f over change in t is equal to f prime at some c value. They're giving me, they're saying why must that c value exist? So I want to find change in f over change in t over this time interval, and hopefully that's going to be 0. Otherwise, I may have to go in and find a time interval in between 60 and 120 where that's true. But I always first start with what they give me. F of 120 minus f of 60 over 120 minus 60. We have to be able to say that that is 0 or some in-between time interval is 0. Well, f of 20 from the table, f of 120 from the table is 0.1. F of 60 from the table is also 0.1. write that. Don't get sloppy and not write that step, okay? That might be worth a point, so don't leave it out. And that is equal to 0, which is what we were supposed to have it equal to. So a little check mark on that, okay? What is required here? Yes, you must say that. You must write this notation, and then say this, and then say 0. So, there must be a C in between 60 and 120 such that f prime of C is 0. We used MVT, but we don't have to say that we used MVT. We just did it. Okay, part C. So far in this calculator active question, we have not touched our calculator. Something about part C is telling me we're going to have to start to touch our calculator. The rate of flow of gasoline in gallons per second can also be modeled by G in between 0 and 150 seconds. Okay? Using this model, find the average rate of flow of gasoline. The average rate. G is the rate of flow of gasoline. We want to find its average from 0 to 150. So I pull out of my toolbox the average value of a function formula, which we must know. The average value of a function formula, 1 over b minus a, integral a to b, of the function which we are averaging, and we are averaging g. You can think of this as adding up what you want to add up and then dividing by the number there. You can think of it that way. Okay, now we're going to go to our calculator finally. Okay, so I'm going to put this in for y1 carefully. T over 500 times, T over 500 cosine of T over 120 squared. Make sure that you're squaring both the x and the 120. And then I'm closing the parentheses on my cosine argument. Okay? And now on my home screen, I type in this integral. 1 over 150, math 9, 0 to 150 of y1 dx. And I got 0.095. You can write that. You can write a couple more decimal digits if you want to. But you must give at least 3 decimal places. They would only accept an answer of 0.095, or in this case 0.096 because of the 9 behind the 5. These are the only 2 that they would accept, and they will only look at the first 3 digits. The next digits could be wrong, and they don't care. They will only look at the first 3 digits. They have to be either a 095 or a 096. Okay? All right, that was short and sweet. Now we go on to part D. Using the model defined in part C, find the value of G prime of 140. G prime of 140. Well, I have G in my calculator. I can certainly take a derivative using math 8, right? So we're taking the derivative with respect to x of y1 at 140. And once again, I need to write at least 3 digits after the decimal point. At least 3. If you want to write more, that's fine, but they will only look at the first 3 for accuracy. So what numbers would they accept here? They would accept 0.004 and 0.005, and they will not look at anything else. They won't even consider those remaining digits. They will only see if those are correct. All right, let's go on with part D. Now it says interpret the meaning of our answer in the context of the problem. So G is the rate of flow of gasoline. What would G prime be? G prime would be the rate at which this rate is changing. Now in this one, they did not say I had to use correct units. I'm very used to using correct units, so I probably will use correct units, but since I didn't say to use correct units, they're not looking for units in our answer. Okay, so I will say at time 140 seconds, the rate of flow of gasoline being pumped into the tank is changing at a rate of G prime of 140 gallons per second, or you can say gallons per second squared. Okay. All right. Let's see how they scored that this year, last year. Okay. Part A. I'm looking over here now. Okay, Part A, they gave 1 point for interpretation with units. They gave 1 point for the form of the Riemann sum. And they made a note that said there are 6 values here. 5 of those have to be correct. So 5 out of 6 have to be correct in order to get that form of the right Riemann sum point. And then 1 point for the approximation, in which all of them must be correct. To get the approximation point, they all must be correct. Part B. In Part B, they gave 1 point for saying that f of 120 minus f of 60 is equal to 0. Okay? And they gave 1 point for the answer with justification. So that would be yes, there must be, and then the second point, you had to say that f was continuous and differentiable, and why. You had to say this, and you had to give your answer. So the answer with justification point, that was a more difficult one to get. Part C. 1 point for the average value formula. Does this student know the average value formula? That's what they're wondering. Okay, 1 point for the answer. And can I cram in Part D here? Part D, 1 point for G prime at 140. Is that correct? And then 1 point for the interpretation. Okay, so our average for that one, 6.3. Global average 5.3, Texas average 4.8.